The question we are solving now belongs to test series 3. It is of control system subject. In specific, it belongs to Bode plots. As per the question, the Bode magnitude and phase plot of a control system are as shown. The mode magnitude plot has an initial decay of -20 dB per decade, and after that it was flat for some range of frequencies, then again it decays at -20 dB per decade. The phase plot is as shown. It's given that the reference point for the phase plot is -180 degrees and the reference point for the magnitude plot is 0, and the x-axis is the angular frequency in radians per second. There are totally 4 statements given as related to this Bode plot. The statement A is type 2 system, and statement B says that the control system's open loop transfer function g of s multiplied by h of s has a pole closer to origin, and the statement 3 says that g of s into h of s has totally 3 poles, and this is option C. And the option D says that the gain crossover frequency omega g is greater than the phase crossover frequency omega p. We need to find the correct option out of these 4. From the given data, we see that the initial decay of the Bode plot is -20 dB per decade. So we know that if a system is of type n, the initial decay will be -20 n dB per decade, and this is equal to -20 dB per decade. From this, we can say that n is equal to 1. So the system is type 1 system. So the option A is not correct. Also, from the magnitude plot, we see that the Bode magnitude plot becomes flat after some time. So from this, we can say that initially there is a pole at 0. Then in the increasing order of omega, then there is a pole, and after that there is a then there is a 0, and after that there is a pole, because the steady state decay is -20 dB per decade. From this we can say that accepting the pole at 0, g of s into h of s has a 0 closer to origin than a pole. From this we can say that the option B is also not correct. Also, from the above data we see that there are totally 2 poles, but option C says that there are totally 3 poles, hence the option C is also not correct. Now, as per the option D, it is given that the gain crossover frequency is more than the phase crossover frequency. We know that gain crossover frequency is the place where the magnitude is 1 or it is 0 in dB. From this we can say that in the given plot, gain crossover frequency is located at the point marked. Also, we know that the phase crossover frequency corresponds to a phase of -180 degrees. Hence, from the plots we can say that the phase crossover frequency corresponds to the point marked. From this we can say that gain crossover frequency omega g is greater than the phase crossover frequency omega p. Hence, the option D is correct. So from this we can say that the correct option out of the given statements is the option